So hello everyone, I'm Ram, ex-Autotox, and now part of Qualcomm. So we are now part of Qualcomm Auto BU, and I'm part of the product management team that is responsible for the V2X SoC lineup. And I really appreciate the reorganization of the order, because the perspective of the OEM and the city, four-wheeler, two-wheeler, bicycle maker is super important. What the dimension that I will bring into this discussion is the SoC maker perspective. How we take all these diverse set of road users that bring different requirements, different considerations, and try to harmonize, because harmonization is key to scale, and scale is important for cost, and cost is essential for market creation, especially for a market that is catering to a very broad and diverse spectrum of use cases and users. So I would like to start with a first quick look at the cut-out scenario. So it turns out this is one of the most challenging scenarios for traditional AEB that is using line-of-sight sensors. And there is a very famous viral video going on of the Dongshedi test in China showing 31 cars out of 36 that fail the cutout scenario. Now they fail the cutout scenario not because ADAS sensors are bad or not performing well. They are simply reaching the physical limitation, right? Because when you are on highway at high speed, time to collision gets shorter, and then line of sight comes late, too late. And the capability of vehicle to rely only on line of sight in this scenario to brake on time is very limited. This is where we are reaching the physical limitation, and this is where V2X essentially shines. But other than elevating ADAS and elevating AEB, V2X is a technology that is also inclusive of other road users. So this is maybe something that I want to show in this video. So this is a demonstration that we did not long ago here in North America, showing cutout scenario involving car and two-wheeler. So again, this is where the non-line of sight capability enables early alert and later on also vehicle control to maneuver safely to adjacent lane, also while enabling convenience, right? So not every safety event should end up with emergency brake. If you have information ahead of time, you have the capability to coordinate the maneuvering in a way that is very smooth and also convenient to the rider. So V2X is about democratization of safety. So safety should not be reserved also to cars that have a lot of real estate to put many sensors and are less cost sensitive, and these are the privileged road users. So safety should not only be reserved to privileged road users, but it should cater to all. And V2X is very unique because it's a common denominator technology that can really elevate the safety for all road users, all the very broad spectrum of road users. So while vehicles are coming today as a standard with ADAS sensors, it is very hard to imagine, if you look at the other side of the spectrum, vulnerable road users or pedestrians carry cameras or radars for safety. On the other hand, we all carry communication devices in our pockets, around our wrists and earbuds, so we know how to live with communication very seamlessly. So it's very natural to augment safety on top of the other services that communication delivers to the pedestrians. So understanding that the only way to include pedestrians in a safety network is through communication, it underscores the immense value of V2X, but it also maybe give hint about the challenge of harmonize. How you harmonize such a broad spectrum of users that come with different set of requirements and constraints. So I mentioned briefly at the beginning that harmonization is key to scale, and scale is very important for cost reduction and market creation at scale. And road user diversity is a challenge, and Bob mentioned many of the challenges of acoustic two-wheelers. I will use the term from now on. So this is very, let's say, extreme type of road users, again, from architecture standpoint and difference in architecture between vehicle and bicycle. But yeah, this is by no means an exhaustive table, but just to give a hint about the fundamental differences between the different type of road users. So the role that each road user has is different. Some road users are more on the offender side, some road users are more on the victim side. It derives certain requirements on the system, right? So while for bicycle, oftentimes you can say V2X beaconing system can be a very good entry point to this category. Beaconing alone on the vehicle side is not enough. This is clear, right? Because as offender you need to receive information about and have awareness about known line of sight hazards. We talked about power source, active safety and capability to integrate with active safety, installation space, cost sensitivity and so on. So again, as an SoC maker, we need to look at it and see, okay, we want to create a market. What is the right strategy for us and what architecture we should target in order to maximize harmonization? Now, attempting to harmonize across the board, it's a nice idea in theory, but in practice, it will result in suboptimal implementation across all the categories. And this is something that we need also to avoid and be minded of. But it turns out it is possible to harmonize across passenger cars, PTW, and e-bikes. And this is something that was a very important consideration and driver in the SoC strategy that we came up with. So it turns out that the V2X SoC architecture that maximizes harmonization is a standalone V2X SoC. And why? So if you look at the left-hand side, you see the higher-end vehicle category and premium motorcycle. So for these road users, standalone architecture brings the state-of-the-art cybersecurity architecture and also enable higher level of automation using V2X data through functional safety implementation. So standalone delivers merits in this respect, allows integration with ADAS, ARAS, and so on. If we look at the right-hand side, standalone architecture is an optimal architecture as well, but maybe from different consideration. So you want to have something that is pretty tiny, you want to have something that is pre-integrated. Bob mentioned the lack of know-how and expertise from R&D standpoint, as opposed to automakers that have been experimenting nearly 2 decades with V2X. This know-how and expertise is not there in the bike or e-bike category. So having something that is really standalone, pre-integrated, pre-validated, pre-certified is something that is really optimizing this category. Of course, this allows a shrinkage of and miniaturization of the system footprint, cost, and so on. And at the basis of all of this is harmonization in terms of standards, message set, and so on. And this is something that is already available, profile available, messages are available. And further work on that topic is being done as part of the industry organizations that are leading this Connected Motorcycle Consortium and Car4Car, Coalition for Cycle Safety. So a quick look at Europe. So Europe is a very interesting region in respect that first it's very advanced in terms of deployment status, but it is also the first region that we will see different categories of road users communicating with one another. So there is already a very strong commitment from the leading European OEM to deploy at large scale. So Razvan mentioned yesterday north to 2 million cars already, and this is expected to grow. We know about other OEMs that plan to deploy in the coming years, including heavy vehicles and so on. There are two-wheeler deployments that are happening, so several premium e-bike makers already committed to deploy the technology in the region, and there are motorcycle makers that are going to join soon. And from infrastructure standpoint, so this is also happening at scale. So thousands of roadside units are being deployed, and this is actually an active public safety service in Europe today. So this is, I think, a very good example of a region that seeks solution that harmonize across multiple road users, and we expect to see these types of road users already communicating on the road as early as 2027. So I will end with a little bit forward-looking perspective on the multidimensional evolution of V2X, and this is again something that of course is driving the SOC strategy, because when you develop a system for a vehicle, four-wheeler, two-wheeler and so on, this system should be capable to evolve over time to support more advanced use cases. And we need to be minded about it. So it's not only about how to harmonize between different road users' requirements and system architecture, but also to make sure that we support the evolution of V2X and evolution of use cases across these different road users. So there are three vectors that I will highlight today. So if we saw in the early days of V2X very high focus on V2V and V2I, what we see as a next step is transition from V2V and V2I to V2X, basically communication with other road users. And there is a natural evolution. It will not go from cars to pedestrian over one generation of product, but we start to see surging demand in the micromobility industry, power two-wheeler, e-bike and so on, and this is reflected in the projects that I mentioned in the earlier slide. Another evolutionary path is ADAS democratization. So we are now transitioning from individual perception to cooperative perception. Right? Now we harness the fact that there are onboard sensors on cars, and we can leverage V2X in order to augment and relay sensor level information with cars that are not equipped with ADAS or equipped with ADAS but do not have line of sight to ADAS systems of other cars. So this is a very important power multiplier that requires advanced standards and technology that can transmit bigger messages and also communicate in a more effective fashion. Another vector is transitioning from awareness to control. So ultimately, the promise of V2X is being utilized as a sensor that is participating in vehicle control. So this requires a higher level of security and functional safety, so the implementation need to be capable of catering to that as well. And the basis to all of this is global standard support. So as Yannis mentioned, OEMs are largely global, and if we talk about cost as a very important driver, we want to harmonize as much as possible the hardware SKU, the software, and the central SoC. So a key part to that is to be capable of supporting all the different standards that are being implemented in different regions. So if you talk about Europe, so ITS-G5 is being used. If we talk about China, North America, so LTE V2X was picked as a technology. And now we see 5G V2X as some sort of expected day-to technology across the board. So this is something that is essential to support all the harmonization aspects that I mentioned earlier today. So with that, I will end this session, and if there are any questions, so.
Good morning, this is Christian, Coalition for Cycle Safety. Thanks for mentioning. Great presentation. I would like to touch base on what you have said, economy of scale. So we need to have volume in order to bring down the cost. On the other hand side, we have heard today from Bob and from Tsukamoto-san the topic we need to have really an acceptable. We are very price sensitive. So we have here a dilemma, and I would like to understand how SoC companies can respond on that one. Yeah? In the first times where we don't have really penetration, we don't have really value we can present to our customers. But the cost is high. So this is contradicting. So this is a lot of responsibility, I think, SoC companies have on their shoulders. How you can manage that one?
So it's a good question, and this is where harmonization is key, because if different road user would require a different SoC, you cannot capitalize on volume that is being generated elsewhere in order to improve the economies of the SoC. So if we are capable of solving this equation and offering an SoC that can be used in cars, but also can be used in the premium category of bicycle, e-bike, for example, then the e-bike industry can benefit out of the scale that we have elsewhere. So this is the importance of harmonization. Now, of course, as the market is in the beginning stage, the cost structure is different, and of course, as scale grows, the capability to further optimize the cost is improving. But this is the rationale behind the SOC strategy, to try to harmonize across different road users, so each road users can harvest the value of penetration across other categories.
Thank you.
Another question?
Thanks a lot for presentation. I have just one question. I know that you're working with iPhones, etc. Why Traction is not doing this two-step strategy? First one to integrate this topics and the SOCs in the phone, yeah, because it's very easy. We have the capability to do that. I think you know that. And the second step, to work on this to adapt it for the other business models.
So it's a good question, and I think this boils down to how the use case space is split across different types of technology. So I think this connects also with what Yanis mentioned about connectivity with the cloud for awareness, for latency tolerant use cases. So this is something that might be relevant for cellular connectivity. But when we talk about classic safety use cases, hard safety, where latency, quality of service is key, integrity, so then direct communication is essential. And this is something that is right now cannot be incorporated in a seamless way inside a smartphone device. But again, I talked about the harmonization across the four-wheeler and high-end two-wheeler and e-bikes. The next generation and the evolutionary path of V2X will take us to support acoustic bicycles and pedestrians. So this will drive us to a different type of architecture that is catering to this type of category. It could be incorporated into devices like smartwatch and also devices like smartphones and so on.
Thank you, Ram.